Perfect. Okay, hello everyone. Happy to see many people joining today. So yeah, I'm Kai. As Julie already introduced me, I'm a PhD student at TH Zurich, where I research clouds and the atmosphere using machine learning techniques. And I'm also a core team member of Climate Change AI, which is an international organization that facilitates the research in tackling climate change within. Today I'm giving kind of a broad overview of how artificial intelligence or machine learning can be used to tackle climate change. So this talk will be suitable for all levels. It's not very technical, and I hope at the end you will have a good understanding how we can use machine learning to fight climate change. First, I want to give a bit of an introduction of the current state of climate change at the moment. I guess most of you who attend this talk today are generally interested in the topic and aware of it. But yeah, just to get everyone on the same page, I want to give a bit of a broad introduction. So maybe some of you have seen this picture here, and at the first moment it looks quite innocent and maybe even visually appealing. But what it actually shows is it is the warming of our planet. So these bars each represent either like a warming or above average temperature or below average temperature year, and red marks hotter than average and blue colder than average. And we can see that basically for every of the last years, we see this trend that the years become warmer and warmer. And this is on the pictures on a global scale, but basically the same pattern can be seen for every country. And some countries it is more extreme, like in the Arctic, for example, we have like a lot stronger heating. But in general, yeah, we can see this trend, and it's quite alarming, obviously, that we see this pattern. To give a bit of a more in-detail view, I want to show you a few slides from the latest IPCC report, the Intergovernmental Panel of Climate Change. And this is written by the leading scientists in the field, also lead authors from ETH Zurich and University Zurich are always contributing to it. And I can really recommend you to also look at the short summary. It's 39 pages long, and it really gives you a good overview of the current state and also the potential future. What we see here is in green, the simulated temperature change of the last since 1850 until today, basically. And we see that there is not really much change if we only have like the natural, so only solar and volcanic activity. If you look at the brown curve, this is the including the human actions, so all the CO2 that we emit. We can see that there is a clear trend to warming, and the black line is actually the observed temperature. And what the IPCC report finds is that we already have now a warming of 1.09 degrees and 98%. So basically everything is due to human action. So it's anthropogenic climate change. So yeah, basically this plot alone is enough to see that we have a big problem and that the climate change is real and already happening now. So it's not something in the future, far distant, but something that is happening right now and in the last years. And as you can see, it's picking up pace. Just one more maybe tangible example is also from the IPCC report. It shows the increase of extreme heat events since 1950s. And we can see that basically everywhere in the world where we have data, we can see a strong increase between medium and strong increase of heat events. So this again shows the severity of the problem and that we are already in the middle of it. Okay, so but this is the current state. Most of you are probably familiar with that, but how can the future look like now? Also, in the IPCC report, we kind of the authors tried to answer this by creating different socioeconomic scenarios. So what you can see here is the carbon dioxide emissions in gigatons per year for different economic pathways that we as the humanity basically can take. And this ranges from the light blue one, where we go basically negative emissions, starting from 1950, to the dark red one, where we're just emitting more and more CO2. And even with the best scenario, what we see here in the next plot, we kind of reached we basically reached the 1.5 degree goal of the Paris Agreement. So it really shows us that we have to act now and to reduce greenhouse gas emissions drastically. And maybe also just the difference between 1.5 degrees and 2.2 degrees to emphasize on this. So if we have a 1 degree increase in global temperature, extreme heat events, like 50-year extreme heat events, are 5 times more likely than in the past. If you have 1.5 degrees, it's 9 times more likely. And if you have 2 degrees warming, it's 14 times more likely. So we can see here that it makes a big difference if we have 1.5 or 2 degrees, or I think this is the maximum that we should aim for. But as we can see here, there are many scenarios where we shoot well above this threshold, and we should really try to avoid this. Okay, so now this obviously is always a bit depressing, I think, seeing the current state, but also the future. But what can we actually do to contribute to help tackle climate change? So as I said, it's not an on and off switch. So it's not like something we do one action and then climate change is solved. It's really a global effort that has to be done over many, many years to tackle climate change, or to try to reduce the severity of climate change. And basically the most important thing we have to do is reducing the greenhouse gas emissions. As we saw in the previous plot, there's the clear connection between the greenhouse gases and the global average temperature. And we cannot really stop it anymore because we already have 1 degree warming, but we have to try to slow it down and to make the impacts less severe. Because we cannot really stop it anymore, we have to also work in climate change adaptation, meaning that we have to be more resilient to the consequences of climate change. For example, to extreme heat events, to floods. Here we have to develop maybe new crops that can grow under the new conditions. So these are the 2 main pillars that we have to work on. First, mitigation, and then second, also very important, is the adaptation. And where can we do mitigation? Here this plot shows the sources of greenhouse gas in 2016, but it's still valid now today. And we can see that across all industries, greenhouse gases are emitted, mainly CO2, but also methane is an important greenhouse gas. And this looks like there's so many problems, which is true, but this also means there are many possibilities for us to work on and to try to reduce these emissions. So where can AI, data science help to tackle climate change, to reduce the greenhouse gas emissions and to increase the adaptation? And first, maybe because I don't know about the audience, but I guess there are a few people also that have a non-technical background. I don't really want to go into too much detail today in the technical terms in my talk. I'm happy to discuss it afterwards if there are any questions. And throughout the talk, I will use machine learning and artificial intelligence interchangeably, although it's not perfectly technically correct, but for now it should be fine. And it's also done like this often in the mainstream media. So in general, machine learning is a group of techniques that helps us to automatically extract patterns, connections from large amounts of data. And the strengths that the machine learning gives us is that we can scale human insight to very large scales by analyzing large amounts of data, where we before would have needed really experts, humans in the field. Machine learning can optimize or automate a lot of these tasks. We can optimize complex systems like climate models or energy systems with the help of machine learning. And we can also generate new data where we may be missing data for a certain application, but have a similar data set laying around somewhere. And then we can kind of generate new data based on other data that we have. And what happens now recently in the last years also is in integrating with other methods. For example, combining machine learning with physical models, and thus kind of combining the strength of both worlds. But of course, now half of the slide is still empty. We have also problems or weaknesses or limitations with machine learning. So one big problem is that the model can only be as good as the data is. So if we have, if the data is not good, we also predict something bad. So this is one problem that we as practitioners have to be aware of. Also that biases that exist in data or the design of the architecture kind of carry throughout the model, and that we as practitioners have to be aware of certain, or research our data set for certain biases. Especially with climate change, it's important for us to know that if we train a machine learning model on historical data, what we often do, that it can be difficult to predict the future with it if the system is changing. What is happening now in climate change, right? The future climate will look different from past climates. So if you try to predict the future climate only in historical data, this won't work. And finally, if you've ever taken a stats class, the first thing you learn is correlation is not causation. So often what happens, you have like a high correlation efficient and you're happy about it, but then in the end, maybe something else is the cause and what you're actually interested in. So yeah, this we always have to consider as well. Okay, but despite all the limitations, machine learning is a very powerful tool. And a few years ago now already, the founders of Climate Change AI and advisors have published this paper, Tackling Climate Change with Machine Learning. Maybe some of you are already aware of it. If not, I can also really recommend to have a look and read through this paper. It is a over 60-page summary of many applications and different industries where machine learning can be used to tackle climate change. Especially, I think it's a very nice paper if you are currently like wanting to get into the field but are not sure like where to start, then this paper is a really good starting point. So in this paper, the authors identify different industries where machine learning can be especially useful, and these different sectors here kind of resemble quite well the chart that I showed before about the greenhouse gas emissions. So we have the electricity systems, buildings and cities, transportation, farms, forests, industry, climate prediction, and societal adaptation. And there are many examples where machine learning can be used. I want to take a bit of a different approach today to show you examples in that throughout these sectors, we have recurring themes. So patterns that are recurring across the different industries. For example, forecasting is used in different sectors, and the other themes that I showed here as well. And in the following slides now, I want to give one example each for these recurring themes. And the good thing about this is that these themes are not new to climate change. but they have been studied in other contexts extensively. So we can really build on other research that has been done in other machine learning or other contexts and use techniques that are already available. Okay, so let's start with the first theme, that is forecasting. And this here is an example from Open Climate Fix, which is an NGO or a non-profit organization. And what they do is they try to forecast solar and wind power production. And this is especially necessary now that we move from very centralized energy production to decentralized energy production with many small producers. For example, if you have a house and you have solar panels on top of it, and with using weather data and historical data, they can do short-term forecasting of the energy supply, and thus help manage power grids. And they use time series algorithms, as I said, learning patterns from historical and weather data. Then the next theme is data mining, which is basically finding the golden nuggets in large amounts of data, or also data generation. And this example I particularly like. It's from also people from Climate Change AI are involved in this. You can visit this website later. It's called This Climate Does Not Exist. And what they do here, they show kind of your local neighborhood, and they show how it will look like in 30 years or so when the climate change is really severe. And what they try to do is just bringing attention to the topic by showing like this is what your neighborhood will look like if you don't do anything. And also from a machine learning perspective, it's interesting because they use images from real disasters and then learning kind of the patterns from it, but putting it on just Street View images from Google Street View. So it's a generative model that they use here. Then the next topic is remote sensing or satellite imagery that is heavily used in different industries or scientific applications. This is one application here where they monitor the crop yield in drought situations or excessive rainfall, and thus help informing farming policies and catastrophe management by using computer vision algorithms on satellite data. So the next topic is approximating time-intensive simulations. And the example I show here, this research that I was involved in, that's not yet published, but hopefully soon. So what we did here is, if you remember from the beginning, the IPCC report, we had different scenarios of different socioeconomic pathways, but it were only 5 scenarios. The reason why we only have 5 scenarios is that it's very expensive to calculate the climate models because they run on supercomputers, and it's just a very computationally expensive effort to do so. And what we did here is we emulated the climate models based on a machine learning model, and now we can interpolate between the scenarios. And now policymakers can basically just put in the CO2, CH4, and other values in the machine learning model, and then it kind of outputs the global temperature change. So thus really, reducing the time and making the application easier to use. The next theme is accelerated experimentation. And this example here is from the research and development of battery technology. And here machine learning really is used to try to find new materials or try to recommend which material to test next, because often experimentation is very expensive to do so. And here AI cannot really replace the process of scientific experimentation, but it can be used to analyze patterns in the past and then recommending which material, for example, would be a good one to try next. Okay, only 2 more examples left. We have optimizing systems. This is a very recurring pattern. Every time you hear like optimizing something, machine learning is usually a good fit, because we can learn based on historical data and past data, really the optimal policy, which is, for example, in the heating of buildings, heating, ventilation, and cooling. They contribute over 50% of the energy use. And using automatic control strategies, turning on the heating on and off when necessary on the right temperature, can be learned with machine learning, for example, with reinforcement learning, and thus reducing the energy consumption by buildings. And the last theme is the predictive maintenance. Maybe some of you have heard of this already. What this means is that we want to kind of not wait until something breaks, but forecast when we have to, for example, change out a railway. This is an example from Deutsche Bahn, the German railway, where they put in sensors in their rails that should alert them when the rails are soon to break, but kind of before it happens. So thus making it more efficient and cheaper in the end, the railway and transportation, and which is a critical system to decarbonize and replace passenger and freight transport by car, trucks. Okay, so now you have a big overview of many potential applications. However, this is still like only scratching the very, very surface. And in the recent years, the research in machine learning, tackling climate change has really, really picked up pace. And there's so many conferences. We at Climate Change AI also organize workshops at the big machine learning conferences, but there are also many more. Also, the investment in companies that use machine learning to tackle climate change are really on the rise. So there's a good momentum, and it doesn't look like it's going to slow down anytime soon. But now we saw all these cool examples, but of course there are also some considerations that we have to make. So first is that machine learning is only a tool. It's not inherently good or bad, but it's in the end, it's what we as humans use it for. So the examples before are examples where it is used, in my opinion, at least in a good way, but there are also applications where it's used in a bad way or harming for the climate. So for example, it can be used for oil and gas exploration to find new oil fields, to optimize oil platforms, etc. So yeah, this just shows you that there is also many potential harmful applications. And also the training of these machine learning models can be very costly in terms of energy and thus producing emissions. Especially large natural language processing models are very costly to train. So this we also have to think about when using machine learning. Also often it is cool and fancy to use machine learning, but it's not the right fit for a given problem. So sometimes maybe there is not even a technical solution needed, but we just need better policies, other ways how we consume, how we do business, etc. So yeah, machine learning is often not needed, and sometimes if you need it, also only a simple regression model or so does the trick. And in the same line is that it can only be one part of the solution where it is applicable. So for example, if we look at buildings, just insulating buildings in a better way is more important than having a smart building, or it has a bigger impact. So yeah, this just shows that it can be useful, but it can only always be one piece in the big puzzle of tackling climate change. We also have to consider downstream effects. So for example, a rebound effect. This means that if you make something more efficient, optimize it more, might be used more afterwards. So for example, if a car uses less fuel, it is, first of all, it's good for the climate, right? Because it uses less fuel. But then if you use it just twice as much because it's cheaper for you to drive around, and yet we have in the end more emissions, that's called the rebound effect, that optimizing something or making something more efficient not always leads to a reduction of emissions. So we always need the right policies also around it to really achieve our goal. Then, especially in this field, it's really important that we have a collaboration of the different actors, so that we have people that are experts in the domains, in electricity, transportation, climate science, working together with the experts in machine learning and joining forces, learning from each other, and also collaboration between academia and the industry. And lastly, of course, there's no impact if we don't deploy our solutions. Now, most of the solutions I showed before are in an academic context. If they just stay in academia and are just written on some paper, it also doesn't help us so much. So we also have to, as scientists, but also people in business, we have to make sure that we also deploy our solutions and that they don't stay just nice use cases that we can show off. Okay, now to kind of overcome most considerations, I want to introduce climate change AI. So we are an initiative that wants to facilitate the work in climate change and machine learning. As I said, we organize conferences, we have monthly webinars, we have a wiki, etc. So we really want to be the platform and the starting point for people who are interested in climate change and AI and who want to start working on it. Then climate change AI is a very good starting point. You can visit our website, it is screenshotted here. I really recommend also to sign up for our newsletters that we have over 8,000 people signed up for. It's a monthly newsletter that gives you the kind of the best information condensed in one email every month. We have this relatively new community where we also have now almost 1,000 people that just discuss topics in climate change AI if you want to find a collaboration partner, etc. But also if you just want to inform yourself, you don't have to be working in the field, but just if you're interested in it, make sure to check it out. We have the papers that were published at our workshops with the search engine therefore. So if you're interested in a certain topic, you can just search for the papers, and we also have the wiki. So you see there's a lot of information out there. If you're interested, just go on our website and then you find all the links. Also the climate change AI directory, where you can find people who are working on certain topics. Yeah. And last but not least, the happy hours. Every 2 weeks, we kind of host this happy hours, just a very informal gathering. If you're interested in the topic, just drop in on the 1st or 3rd Wednesday of the month and let's have a chat. And if you have any questions about how to get involved or learn more about climate change and AI, let me know. And yeah, I'm very happy now to discuss the topic, maybe also have some controversial questions. So thanks for your attention, and I'm looking forward to a good discussion.